Okay, welcome guys. So this is the first problems related to the probability and the birthday. Okay, probably this is probably difficult question I see in the birthday problem. Not very difficult, but still challenging. Okay, so labor laws in I okay. Erewhon require factory owners to give every workers a holiday whenever one of the day, then have a day led to hire without discrimination on grounds of the birthday, except for these days they work for 365 day a year. The owners want to maximize the expectation total number of man days worked per year in the factory. Then how many workers do factory have in Erewhon? Okay, so let me explain it. So suppose you have one man, then they work 63 they work these days because at the birthday time he do not have to work. Suppose you have two men and they have different uh they have this, right? Because if two men they have different birthday, then you have 2 times 363. So 2 times 363, so it's closely to read this. So this is approximate. If two men have the same birthday, then their working time is this. Okay, so you expect there are when at the beginning when there are more men, then they should work more days. But the problem is if you have more people, then they will start filling out all the year. So somehow that if you have infinite people, then basically all the day, so every day will be someone's birthday. So if so every day could be someone's birthday. So if you have infinite peoples, then the working holiday is zero. So you know that there must be some points that we should cut off. Okay, when you are ready, then we can start. Okay, so what we need expectation of the people work, right? The total work. Basically, just suppose you have let me see. Suppose you have n people. Okay, I let 365 to be large n. Then just n times each people. The expectation of each people were working days. Okay, suppose we have n people. Okay, then we want to compute this. Okay. Okay. So let's start. So let me see the first day. So suppose the first day means oh basically you can say that it's January 1st. Okay. So the first day is the working day. So I want to ask about what is the probability that the first day is a working day? Basically, it's one minus because if this first day is someone's birthday, then there's no way that you can get an answer, right? So there's no way that you need to go to work. So the probability that the first day is working day is just one minus one over n because this day cannot be anyone's birthday times n. So if the first day is the working day, then the probability for the first day is the working day is just one minus one over n to the power n because each one cannot because all these n people cannot have this day to be his birthday. And this is the same as the rest, right? The second day is the working day is this. The third day is the working day is this. Okay. So what we have the answer is just uh this is just n times uh uh let me see n times this one times n, right? Because you have so many days in this, so this is your answer. Okay, so what we get the expectation value is just n times n, this one, and we want to ask which n makes maximum. Okay, from this we can get if n is zero, then if n is zero, then the answer is zero. And if n is infinity, then answer is also zero, because this one can be approximated to exponential 1 over n to n. So if n is very large, then you get this, which is zero, Okay. Okay, so there are multiple ways to solve it. Especially if you are very good at calculus, then you can do the calculus by yourself. Okay. Okay, but one simple fact is that we can use the simple way. Suppose this is the function of n. So what we want is function of n minus 1 should be less than function of n, and the function of n should be also larger than function n plus 1. Then if this property exists, then n is the at least the local maximum. Okay, because the theory is because this problem, the variable is discrete. So if we do the calculus, then we still need to find the close integer related to it. Okay, so how about we try this one first? So what we have is this. Okay, so I should cancel this n, because this n does not affect our computation. Okay, so this is the first one, and how about we try this one? Okay, and then we solve this two inequality. What we can get is that so what we have is these two, and these two. So this give you this one, and the second give you this one. Okay, so which you tell you that n must be n minus 1 or n. Okay, so you just plug in and check which one is closer to the answer. Check the answer. Okay, so this is what we have. So suppose we plug small n to be large n. What we have is n. So n squared minus 1 over n to the n. So which is close to n squared to minus n. Okay. So this is the answer. If you plug n minus 1 when n is very large, then the answer is very close. So n is 365. So the answer is close to 365 squared times exponential 365. Sorry about it. Sorry. So this is what I'm writing about. So when n is infinity, then this is exponential minus 1. Okay. Okay. So let me remind you guys that although I already write thousands of times, so this is the important theorem, important limit you need to remember. Okay, so basically this is close to exponential inverse. So the answer is 365 squared times 1 over e. So close to this. So this is expectation working days. Okay. So let me see. Is we find the answers? Yes. Okay. So the expected total number is n squared exponential minus 1, and so each person, the average working day is just divided by n. So n times exponential minus 1. So basically the answer is so everyone just working like 120 or something days. Okay, so I think this problem is somewhat very interesting, and there involves some find maximum or minimum, involves some calculus and probability. So I think it's very interesting problems, and be sure to subscribe to my channel, and you will see more interesting questions. Okay, so good luck.